Okay, so let's create a new file with its part 6 of course. Okay, let's see module. Let's import prelude because we'll definitely need it sooner or later. Okay, cool. So let's see, what do we think I need to, well, I'll do that later. Right, so let's see, what are so right now, until now rather, we've seen a few types, right? We've seen products, kind of like, it's kind of like product AB, right? And this is kind of, you can hold the, sorry, whoops, I should not do that. Products int and so like int and int, and this may be, for example, point, right? This kind of like let's call it point, right?
Yeah.
Right, so you can store two integers. We've seen sums like weeks, right? Like Monday, and well, I'm not going to write everything, but right, just 3 days. Well, let's say weekend days.
Okay.
Right, we've seen functions, right? Kind of like, well, we've seen functions. I'm not going to write that. So the idea is that, for example, what if I want to write a type?
Yes.
So okay, we also see recursive types. That's also an important type part, right? So where we had like a list int, which was kind of like empty lists int, or list, well, cons list int. Well, let's say empty list int and cons list int with int, and then list int as a recursive thing, right? Oops. And I have this here.
I wanted to fix it. Yeah.
And then we also have like string. Why didn't that work? Whatever. Right, and we kind of had this sort of thing, right? So are you familiar from C# with generics?
I'm sorry, can you repeat?
Generics from C#, like kind of like this thing in C# where you have like a type of like list of int or list of string in C#.
Yeah, okay.
So these are called generics, right? List is a generic type. So it would be nice if we were able to have a list, right? Not a list of string, list of int. What if I need a list of points, right? I'd have to do a different type, which is list point, and then like create a new name constructor names, and like this needs to be a list point here. Well, I even made a mistake here, right? I need to do string here and then point here and then list point, and like this is very annoying and hard to use.
Yeah.
And then all the functions that we've defined for list int will not work for list string or list point. And if you recall, there are quite a few, right? We had like mapping and where is it? Was it here? I thought it was here. I guess it was part 3 where we did recursion then. Oh yeah. Right, like, okay, some maybe doesn't work for strings, but maybe you want to concatenate everything, right? So a few operations are different, but then like finding, it should work on any list, and appending and mapping should work, and so on, right? So turns out that you can actually do this, right? That it would be pretty bad if you couldn't. So the way we can do it, you can do data list, and we have an a here. That's like a type parameter, right?
Yeah.
And we can say nil for an empty list here. You can say cons a and then list of a, right? Do you see how they're the same with like all of this?
Yeah.
Okay, cool. Okay, so now we can literally just define all sorts of functions over lists here. So let's try writing a few, right?
Okay.
Let's actually get inspiration from the part 3 and see what kind of functions we wrote here, and see which one. By the way, do you see when I change the file, do you also look at the same file automatically? I don't know how this works.
Yeah. I'm in part 3 right now.
Right. So okay, how can we write this thing like an empty list? So let's see, empty, right? But we want to say something. Okay, so what type would empty have? Well, we can need, like, for any A, it's a list of A, right?
Yeah.
So we can use, like, empty works for any sort of list, right? Empty is any type of list, any type of empty list. And then does it even work?
Definition.
Oh, okay. Wrong spelling. Okay, so then let's say, okay, let's try to build a single element list, right? So one list. So let's say this is a list of ints, for example, right?
Okay.
So this is just const, one, and then empty, right? We could even say nil here, but let's just use the empty for, right? And then toList would be also list int. We could say const 1, const 2, empty. Well, let's do it reversed. Oops. Right, like this. So this is kind of const. Yeah, thank you. So this is kind of like 1, right? This is like empty, and this is like 2, 1, right?
Yeah.
We can also write it just one list here, right? And it's the same thing.
Okay.
Okay. So then let's see, what else do we want to, can we do here? Okay, so let's stop building random. Let's count, right? Let's do a count. So let's see, count. So count would work on any sort of list, right? It doesn't matter what kind of elements you have, you can still count the number of elements, correct?
Yeah.
So that means we can do for all A, right? For any list A. If you give me a list of A's, I can give you an integer, which is the number of elements in that list, right?
Yeah.
So let me implement this one, this first one, and then maybe you can try implementing the next function.
Okay.
Right. So like normally the thing that you can do here is you just pattern match, right? As we've done previously. That's all, everything you can do, and we can do it. Let's do it like this: nil equals to 0, right?
Yeah.
And if you have a const for some value a, right, and some rest of the list a's, usually, did I do that here as well? Oh, we call it rest. Okay, we can just say rest as well. That's totally fine. Then what do we do? Well, it's 1 plus count rest.
Yeah.
Right, and we don't even care what we name this. We can use underscore, right? And it turns out it's literally the same implementation as this, right? Because even though here we implemented it for a list of ints, we don't even look at the values, right? We just look at the
for any kind of type. Right?
Exactly, right? So now we can count this list of int, but we can count any other list as well.
Yeah.
Okay, cool. So let's look at some other functions. Let's keep sum and product for now, although we can go back to it. Okay, so how would find? So let me copy this find from here to here, like the type signature. Do you think you can guess how the type signature looks like? This is a hard question, so if you don't know, don't feel bad.
Okay. Well, I still have to go for all because it should affect all lists, right? And it goes to it still goes to Boolean because it's true or false. That the number or what I'm looking for is there.
Okay, but like, okay, so you've written this part, but like this was the number we were looking for. Like this is the int we're looking for in a list of ints. So you also need to. But then you're saying that we want to look for an integer in a list of a's. What if a is string, or what if a is something else?
Okay, so I'm looking.
Yep, that's exactly right. You usually put it like we order it like this, but that's kind of the same thing. It's also fine. We put the a first. Okay.
Yeah,
so now
that makes the most sense. Yeah.
Okay. So okay, let's try writing it, right? So this would be something like we're looking for a, right?
Yeah.
And then what can we do next? Like what do we usually do?
Well, now we account for the null.
So we pattern match, but yeah, we start with the nil case. Do you want to write it, or do you want me to write it?
I think I can.
Okay.
But just wait, so I can move the. Okay, find a, but my brain just died. It's actually amazing. Find, so if it's empty, right?
You can't say empty. Okay.
Yeah, find a.
Like look here, it's kind of the same thing that you need to do.
am like this.
Yep, exactly. So that means if I'm looking for a value in an empty list was okay, exactly. And of course, you don't even need it, right? It's this, right? You don't care, but that's fine. It's not a problem.
Okay, and now we have to find A in. So now I have to pattern match, right? Because it's find A in a.
Yes.
I mean, this one matters actually. I
Yes,
think, right?
it does exactly.
Equals 2, and this should be. Give me 1 second, please.
Maybe you can try saying in words what you're trying to do.
Okay, so I need to eliminate the first element, which is gonna happen if I. So what I know for sure is I have to apply the find to the rest.
Okay. Right? But like, be careful because find takes two. Look at how find looks like. It takes an extra parameter.
Yeah.
Okay. Yeah, that's good. So, but then so this is you need to look in the rest of the list in case it's not like in case you didn't find it, but don't you have
can I go for an if here?
Yep, sure.
I mean if wait. No, I am actually doing something really silly here. So if A is equal to Y.
Give me 1 second. So usually when you have this, just to make it easier to like format it, you just put the if on the second line, right? Instead of, because otherwise you'll have to do like 20 spaces.
Okay. Yeah.
Okay. Cool. So that's
if A is
correct.
Equal to Y, then I go for true.
Okay, don't forget because no, you need to. It's like if, then
then
else,
true.
right?
Yeah. Sorry, I was still thinking of past exercises. Else.
Okay.
Find A in rest.
Perfect. And now let's save, and then we'll see we have one error, and let's see if you can figure out.
A equal Y. No type class instance was found. Okay, give me 1 second, please. So it does say it has something to do with type class.
So it's saying that it cannot. So the literal error message is no type class instance found for EQA, right?
Yeah.
So do you have an idea what this means? I've never taught you this, so it's okay if you don't understand it.
Wait.
So what it's saying is
I could be replacing this with.
it's literally the same error. If you do this, you'll get the same error message. EQ and equal are literally the same thing, so that doesn't really help. No, it's correct. The code is correct. You can type it again. A equals Y is correct. So the thing is, if you're saying that this needs to work for any A, right? Yeah. But if it's any A, this A might not you might not be able to do equals on it. It might not have an equals instance, right?
Yeah.
So in order to actually have make sure you just need to do this here, and then your error goes away.
Okay.
You're kind of saying, okay, you can use find for any list of A's as long as the A has an EQ instance.
Yeah, it makes sense. Okay.
Right? Because like, how else am I going to look for something if I cannot compare them? There's no way, right? So this has to be there, right? Which means that this function doesn't work on every possible list. It only works on those which have this property, right? With the elements that have this property. So Max Deviant says, did there a teachable moment about Boolean blindness? I think this is not the best example because find is pretty, like maybe filter is a better example because filter usually trips people up way more than find. Because like if you call this function and it returns false, it's kind of obvious that it means it did not find the value there, right?
Yeah.
Let's see, do we have filter here? We don't have. Let's write filter. That's a cool function. So let me explain filter then. So we have for all A, right?
Yeah.
And then given a function from A to Boolean and a list of A, I give you back a list of A. What's the idea here, right? So let's say if we have list 1, 2, 3, right?
Yeah.
And then we want to filter, and we want to filter, let's say out, right? We want to filter out the elements that are equal to 1, for example, right?
Okay.
Then the result should be 2 and 3, right? And how we use this function, we want to say filter equals to 1. And okay, this is how you do it, right? This is a function that tests if it's equal to 1, 1, 2, and 3. Okay, so how do we write this? Well, we have an f here, a function, which we usually call predicate, maybe, because it's kind of like an a to bool, or pred or something. And then we have some lists, right? And like if we have nil, then the result is obviously nil, right? Because there's nothing to do. And then if we have like predicate over cons a and then rest, the thing we do is usually something like, oh, by the way, here, when you did this if, you could also do something like this, right? Instead of the if, it also works, right? You can do like bar a equals y equals to true, otherwise this, right here. We can also do it here, right? So we can do if pred a, so we're saying that we want to remove if this is true, right? So we can say if this is true, then we go filter pred rest, right? We skip this value basically, right? We skip a, otherwise we just do cons a filter pred rest, right? Like if this is true, we remove it. If this is false, we keep it, right? And this will work as we've expect here. But then is this really obvious? Like if you look at this function, is it obvious that it does this without reading this? The problem here is we don't really know what this thing does. Like if it's true, does it keep it or does it remove it on true? Because we might just as well say like do this instead. Right? Yeah. And then like the result here will be 1 in this case, right? And the result in the other case would be 2 and 3. And this is called Boolean blindness, in the sense that, okay, it's a Boolean, but what does true mean and what does false mean?
Okay.
We don't know in this example, right? With find, we kind of know, because it kind of makes sense, right? Find something, false means not find, true means found, right? But here, what's filter? It could be either. We don't know, right? So like the usual solution to this is you do something like this. Something like this, right? So then you do a function to keep or discard, for example.
Okay.
Here instead, and here you can kind of have a like let's say equals well discard once, right? Which is a function from int to keep or discard. So if we get the value 1, we discard.
If it's anything else, we keep.
Exactly, right? This is kind of the same thing as this, but like makes more sense, right? And then here we could say something like case pred a of keep, and then in case of keep we do this, right? And discard we do filter pred rest, and then it's super obvious, right? There's no way you get it mixed, right? And here you say something like discard once, and then you know that's the correct thing, and there's no way you can get confused. And that's what Boolean blindness means, right? This is like you're no longer blind. You know exactly what the point is, right? What this is.
Yeah. Makes perfect sense.
This is filter was cut maybe is a good example. Maybe I'll get to that when I explain maybe, because we haven't gotten. We started with the more complicated. By the way, this is one of the more complicated types that we're going to do today. We'll do easier ones later. Okay, so let's go back. What other functions can we do here? Prepend. We can do both prepend and append. although prepend is trivial. So let's see. We have this prepend function, right? So this is a version for list int. So how would we write it for our list of a's?
Well, again, for all a's, right?
Mm-hmm.
Right. So for all a's,
Mm-hmm.
I should get something. So it's an a,
Mm-hmm.
goes to a, which goes to a, right?
Not really, because it's okay. What does prepend does? So from a value and a list, you give a list of values, right? So it's kind of like so. Let me explain how we want to use this. So we want to use it kind of like prepend 1 over 1 2. Oh, sorry, over 2 3, and then we get back 1 2 3. But we also want to do prepend hi over a list of hello and world, and we get back hi
hello.
Yeah.
World. Mm-hmm.
Okay. So
So
in this
let's
case,
see what I'm not understanding. So
so
for all
if
a's,
this is okay, so let's try to replace it in our head, right? So in this case, what type is a in this case?
in this case, it would be an int.
Okay.
And
But so this is an int, but this is also an int, but we want to pass it a list of ints.
yeah, now I get it. So
And the
this would
result,
be an int, but this would be a list int.
Mhm.
And so okay. So do I have to apply a function here?
No, it's a lot easier. Just list of a here and then here,
Okay.
right?
Yeah.
Because here again, it's a string and then it's a list of strings, right? So we just need to change this. Okay.
Okay. Yeah.
Oops, sorry. Okay, so right. So do you want to try to write? It's actually very simple to write.
Okay. Well, prepend. First of all, if it's empty, right? So if it's a nil.
So
Like
maybe we can pick here at the implementation. Let me copy it here because we've already done this before.
Okay.
But then, I mean, you can continue writing if you prefer. If that's not, if that's a bit confusing for you.
Is it a mistake if I say that if it's the lists are empty, then it should be just a?
Yes, it is, because a. What type is a?
Yeah. Okay. It's an int. I mean, yeah. In this case, it's an int. In our case.
I mean, it could be an int, it could be a string, but it's like a simple type. Whereas we're saying we'll return a list, right? So it's not also a list of a's.
Okay. So do I construct it?
Yep. Exactly. Okay. But then let's look at the like this constructor. So it needs an a, but it also needs a list of a at the end. It needs two things, right?
Okay, so it should get an empty now.
Yep.
Maybe.
It's called nil, but yes.
Yeah.
Okay, that's correct.
Yeah. And now if prepend of a,
It's
we
fine.
have to pattern match again.
But where do we pattern match? Is it the first or the second argument?
No, it's on the second one.
Mm-hmm.
Yeah, so prepend a to the list because it makes sense because I pattern match on the what do I call it, like list
B or whatever. No, because you have a B and then a rest, right? It's again you have two parameters. Okay.
And it equals 2 and goes okay. So
okay.
So it should be A as the first one.
Yes.
Right? And the rest.
But then you're losing B.
I lost the B.
Mm-hmm.
Yeah. Okay, so it should be okay. Does it make sense if I do this?
It's correct. It's a correct implementation. You're forgetting one close parenthesis here.
Yeah.
It is a correct implementation, but you can literally just write it as a rest equals to const a rest. And the reason for this is like you see why? Because you have const a in both places.
Yeah.
And then in the right-hand side, you have literally this thing, right? Either this or this. So it doesn't matter, actually. This is one of the few places where it doesn't matter what type.
Yeah, and I guess this works because I don't have to get rid of the first element.
Yeah, exactly. You don't have to, and I mistyped it, but it's because it doesn't matter what you have, right? You don't have to change anything that from the existing list. You just need to add something.
I just have to add it. So basically, I just reconstruct the list, but the first element is the it makes so much sense. Yeah.
And actually, since the Purescript values are immutable, you cannot change them. You can just create others, and it doesn't even reconstruct it. It creates a new list where it has this thing and then the old list here, right? It doesn't create a new list. Okay, so let's try doing append, right? So how would you type append in this case? So what does append do? Let me write an example.
To the end of the list.
Exactly, right? So append 1 and 2, 3 will give you, what did I type? 1, 2, 3, and 1, right? And it also works for strings and so on. I'm not going to...
No.
So what's the type?
Again, for all types of A, we get A. So it's the actually we add A and we return a list of A. So this is actually the exact same thing like the above.
It looks the same, but it's a different implementation.
Yeah, because I accidentally clicked save. Okay, so append. Give me 1 second to think about it. So, okay. So it should be append of I don't know, A and rest, let's say, right?
Okay. But that doesn't work because const. Let's look at const for a second. Const has a specific order. A has to be first, and then the list has to be the next one, right?
Yeah.
So if you remember when we implemented this, you can even pick here and cheat a bit at this version.
Okay.
The problem is that okay.
Say it, please.
So the thing is, lists are kind of it's easy to do prepend, it's hard to do append on lists. That's the general,
now I remember. Yeah. Okay. So anyway,
so in this case you do have to pattern match.
To a list, right? So what did you say?
In this case you do need to pattern match, unlike prepend. Okay.
Let's say B and the rest of the list, and it equals to B.
Yes.
And now we append A to the rest.
Okay. But then there's so far it's correct, but then if you look at the error, it's giving you a hint.
Yeah, wait. Yeah, I didn't forget that I have to go for the empty list.
Okay. It's called nil, not empty in this case.
I keep forgetting.
Okay.
Yeah.
It's my bad. Actually, we used empty for all the functions here, but it's all. This is the way that it's actually implemented in Purescript. The list has nil and const as the names for the constructors. That's why we swapped here. Okay, fine. So it's const.
I'll get used to it eventually. It's const of A.
And you're missing you're missing.
Yeah, I'm missing. Yeah, it actually needs it because
empty works. I usually use nil here because it's more obvious, but empty it's also because we defined empty there.
Declared it.
Yeah, it definitely works. So yeah, exactly. This is correct, right? So it's kind of like, okay, in order to add something to the end of the list, we kind of need to walk through the whole list, right? And this will keep walking until we find the end, and then we put the element and we're done, right? Cool.
Yeah.
So we will stop right now with the list functions because, well, most of them will be homework, I think, and we need to look at other types because this is not about just lists. It's about the idea of having type variables here, right? So I want to show you a few more types, right? So actually, let me do this. Let's say homework, more lists functions, right? And we'll add them later. I just don't want to forget. Okay, So let's see other types, maybe. So let's look at a few very important types here, right? So maybe is a type defined like this. Maybe A equals nothing or just A. So what does this mean if you look at it? Can you guess?
It means that it can be one of these two values, right? So it can
Does
either
it
be
look
empty
like something similar to like from programming, from other languages? It might not be obvious at first. It looks a lot like things in, for example, C#, where they can be null or not null, right? Because like you sometimes need to do if a or if value is not null, then do something, right?
Yeah.
So nothing, you can think of nothing kind of like null in that sense. Not really, but some sort, right? Because like maybe A means, okay, I either have a value here or I don't have any value, right?
Yeah.
So it's kind of like a nullable thing. Okay, so what can we do with maybes? Well, I mean, of course, we can have value, right? We can have none. And of course, it's for all A. And we can say none is nothing. And we can say 1, for example. We can say it's maybe int. It's just 1, right? And or hello. Sorry. Right, you can do this. So what can we do with a maybe? For example, let's see. What if I want to write something like this? So I want a function called isNothing that takes a. I'm not even going to give it the signature. I'm going to say I want to take a. So I want, if I call none on it, I want the result to be true.
Yeah.
But if I call on 1, I want it to be false. And the same for hello, right? So basically I want it to tell me if it has a value or not, right?
Yeah.
Well, actually the reverse of that, right? If it doesn't have a value.
Doesn't have a value. Or if it does.
Okay, so do you think you can write the signature and the implementation, or do you need help?
I can try. So
start with the name, right? isNothing.
Yeah, it is nothing.
Okay.
And it should still work for all.
Mm-hmm.
So now.
So what's the first argument? What is the argument that it's taking?
It's none. But so it's the A, right?
Is it an A? Because what type is none?
It's a maybe. It's a.
So it has to work for each of these, right? So it has to be a maybe.
Yeah.
What? Maybe A, right?
Maybe A. Yeah.
Mm-hmm. And what does it return?
Is it this or like this?
No, it's a simple one, right? Because it's just a type. It's a regular function.
Okay. So maybe A, and it gives us a Boolean.
Yep, exactly.
Yeah. Okay, I say that. And now is nothing.
Mm-hmm. So what can you do with maybes? There's only one thing you can do, really.
I can.
Like it's literally the only thing you can do with a maybe value.
Okay, so can I didn't. So I have to pattern match again. Okay. So yeah, but
so like if you pattern match, you can see the constructors, right? Like a couple of lines up. Oops. Right. So it's either nothing.
Yeah, but okay. What is this? How I?
Mm-hmm. You don't need the parentheses, but sure, that's no problem.
Okay. Okay, that's what it makes sense to me. Okay. So it's true.
Yep.
But here I can say like, can I just? Okay. So let me ask you something before this. Can I?
Okay.
Okay. Can I say is nothing, and I don't know. I have to. But can I do an if here?
No, you cannot, because like you cannot convert it to Boolean. So there are two things you can like. There are a few ways you can write the same thing, but they're perfectly equivalent. So it's either this, and then you can write here like anything else is true.
It's true. Yeah.
Sorry, it's false. Sorry.
Yeah.
And then let's save and make sure it's correct, right? And then another option would be, let me do like 1, right? You can do just whatever, and this is also correct. We can also give a name to just, of course, like to this, but again, that doesn't make sense because we're not using it.
Yeah.
And one more thing we can do is like we can say this is a maybe, and then we can say case m of nothing, true, and then just whatever false. And I need to rename this, I guess, because we already have a. So these are all equivalent. They're literally the same thing. It's a matter of preference. Okay, so
that's where I was stuck because
there's one more way which I prefer, but and it's case underscore off, and it's the same thing. And the idea is that if you don't add this here, then you can do this kind of case underscore, which kind of looks at the previous argument, right? That is not defined here, and then it's. The idea is I like this because I don't use m anywhere other than here, right? And this kind of like forces me to not use m and kind of declares that I'm not using m. But all four are correct, so just pick whichever you like more and use it. They all work just fine. Okay, so then you can probably guess what I want next. Should we do this just now? Let's do it. It's just his homework. So this is for list. That will be homework. We don't do that now.
Yeah.
Okay, there's one function we didn't do for list, but let's do it for maybes. Okay, so let's say I'm not actually. Yeah, so let's say we have something like I want this function. I want to be able to do this, for example, over nothing. I want to get back nothing.
Okay.
And I want to be able to do map maybe +1 over just 1, and I want to get back just 2.
Okay.
Okay?
Yeah, but I do have one question.
Yes.
What if the just is a string instead? It
well,
won't work. Right?
It's up to you to make sure you can. That is not possible.
Okay. Well, let's start with the name. Okay.
Yeah, I had it written here. Okay.
Okay. So for all A's,
okay.
where I forgot how you. Wait, give me a second to see how you wrote it down. It's not on this one. Do I have to use the one where the equal is?
Let's add constraints at the end if we need them. Don't start with constraints. Just ignore them for now, and let's see.
So for all A's,
So what was the first argument here?
Yeah, I need a function, right? Or
yes.
Let's say f.
But then, like this is the type, right? So how do we write functions as types, right? It was kind of like
it's a to b
a
or
to something, right?
Yeah. Let's say it's a to f.
I mean, it's usual to do b, right? And we'd had a b here and do this. This is more.
Okay. Okay.
Okay.
Okay. And then we have the maybe.
Yes.
Of a, and now it goes to maybe.
Okay.
Right? Because it's either nothing or just.
Yep.
Okay. So.
But what kind of maybe? Because like maybe you cannot write maybe like this.
Maybe of a, right? Wait. Is it maybe right?
I don't know. Let's find out.
Okay. Can I just let this here and?
Actually, you can put an underscore there, and then Purescript will tell you what it has to be after we write the implementation.
Okay. Map maybe. So
okay.
If I get
so what's the first argument?
right? B is the first one that.
Is it? What,
Okay.
Isn't it a function?
Yeah, but should I still write it like this?
No, it's the a to b, like you did in the lesson.
Okay.
Right, it's just a
Map
function.
maybe
Okay.
A to B to
So what can you do? What's the thing that we
I
can
have
do
to
over
construct
maybes?
for the B. Okay, I still have to construct for the nothing case, right? So
Yeah, to pattern match, but yes.
yeah.
Mm-hmm.
Uh,
Yep, correct.
and let's say Y.
Sure.
Um, so it should be equal to yeah, actually.
Okay.
Should be,
Why are you doing plus though? Because like this is a function. So okay, what type is y?
what type is Y? It's a maybe.
No, this is a maybe. Just y is a
Yeah.
maybe. What type
So
is y?
Y can be anything. It's a maybe. Yeah, it's an A. I mean,
It's an a, right? So you just write a there, maybe. Maybe that's going to be easier if you do that. Okay, and a to b is a function which just takes an a, right? You cannot add a function with something else, right? So it's just Okay, so how do you write this? A to b.
A to B, and then
so what? No, so a to b is a function that needs an a to get you a b. So and what do you have?
A to B of A.
Yep, you
right?
just have an a. Okay. So if we save this, if you look at the underscore, what does it say? Up top.
Okay, wait. B0 invariant declaration. Maybe where B0 is a rigid type variable, down that.
I mean, the only thing that you need to look at wildcard definition has the infer type B0. Yeah, exactly. That's it.
Yeah.
It kind of adds numbers for internal reasons, but this is correct. That's it.
Yeah.
Because if you look at it, you kind of like, okay, so I have a way to go from A to B's, right? And I might have a value of type A, right? So what can I get back? Well, maybe a value of type B, right? Because if you have that value, I can apply that function and then convert it to a maybe of B, right? And if you don't have a value, but then I don't need the function. I just return nothing, right? But it's a B nothing, right? Instead of an A nothing. So for example, you could use, for example, show here. And then you get just one, the string one, right?
Mm-hmm.
You get?
Yeah.
And this is a super useful function, right? Because it allows you kind of to use the simple functions you have that operate on like simple values inside maybes, right?
Mm-hmm.
Okay. And then there is one more very, very useful function for maybes, and I will write it, but I will kind of walk you through it, right? It's called maybe with a lowercase m. Right, so the idea is, how can I grab a value out of an out of a maybe, right? So let's say that, and I'll have some things to add here, right? But say I want a maybe a, right?
Yeah.
And I want to somehow extract this value. Well, I cannot really extract an a out of it, right? Because what if I don't have a value?
Okay.
So maybe let's start with the other function. Let's start with from maybe. It's a different function, right? So I have a maybe a, and I want to get back an a, right? How do I do that? Well, what do I do? So I can actually start writing the function, right? So let's do from maybe, right? And then we can say just a, then we can just return the a. That's easy, right?
Mm-hmm.
So what if from maybe nothing? What can we do? Well, we don't have any a, right? So what could be our options? Do you know some?
0, like is 0 something that could be?
If we put 0 here, then a needs to be int, right? So it will only work if a is int. So what we're saying here for all a, right? So that will not work.
So it's nil or something?
Well, no, because we don't know that nil is a possibility. If you say nil or 0, It's kind of the same thing. You're kind of like saying, okay, I want to pick A as a specific thing, but we cannot do that. A is anything, right? So no, because it's not a maybe A, right? We're returning A back, right? So it's kind of like, if you think about it, in C# you can always return nulls when you want. Here you cannot do that. That's a compile time error, right? You have to be very explicit in this. So one way would be, okay, we just pass an extra A, right? Which is the default, right? And then we return it, right? So this is kind of like, okay, if it's nothing, use this value. If it's not nothing, if it's a value, then give me that value, right? So this is kind of like this is in sharp kind of like if A is null, well, something like B equals to, if A is null, then 0, else A dot value or whatever. I don't even remember, right? Something like that. Right, but it kind of like you cannot really, like, instead of 0, right, because you know here that A is some nullable int, you kind of do, it works for everything, right? But you have to give it a default value. Another option would have been to use monoid here, because with monoid you can get the empty, empty. But then it's kind of weird if you use monoid, because then monoid also implies that you're going to combine values somehow, and that doesn't make sense here. So this is the way that this works, and this is a very useful function. But then there is one more, like a function that's a bit more general, and it's called maybe, and it's for all a, b, and you give me an a, kind of like here, like a default value. Sorry, you give me a b, not an a. Then you give me a function from a to b, and then you give me a maybe a, and I give you a b back. And it's very similar to this. Except what's the main idea here? So let's see. Let's try to implement it first, right? So we have a value b, we have an a to b, and then we have either just a, in which case we do a to b a. Right, and we're not using the b. And then we have maybe b, we don't care about the function, and nothing, and we return b. Right, so like in this case it's identical to this, right? To this, the default version, right? But in case that we have a value, we want to apply a function, right? So it's kind of a combination of map and from maybe, in a way, right? Because we want to kind of map the value and also extract it, right? As opposed to here where we're just mapping. And this is also a very, very useful function, and we'll learn a lot more about this sort of functions, but at some other time. They're also called catamorphisms. But we'll learn about this sort of thing later. Okay. So I think that's really everything we want to know about maybe right now, and we'll do, I mean, not everything, of course. There's a lot more to learn about this sort of types, but I want to show you a few more types. So there's, let me think, there's one more type I want to show you before we look into functors. So it's called either AB, and it's left A or right B. So until now we only had one type variable, two types. Now we have two. Right, and it's again it's very similar to maybe, right? Because like this looks like right B is kind of like just. But then instead of nothing, we have a left A, right? So we also have a value on the left-hand side. You can usually think of this as something like A is usually, again, it's not always, but oftentimes A will be the error type, right? So this usually represents like some value of type B, right? But the thing is that it might have errors, like there might have been an exception or an error of type A, right? So for example, let's say that if we want to do something like divide, and you go from int to int to either string int, we can do something like this, right? So for example, if we have anything that and we want to divide by 0, we can do left error cannot divide by 0, right? And then otherwise we can do divide and m equals to right n divided by m. I'm not even sure if you can write this. I guess you can. Right, something like this. Right. So this is like a how should I put it? like some example of using eithers, right? Okay, so like we can obviously do like this, the isLeft function for all a, b, either a, b goes to Boolean, right?
Yeah.
And then what do you think we can do here? Do you want to try?
IsLeft. So, okay, just give me 1 second.
Hmm?
So, what I'm doing here is basically I'm asking if it's left kind of value or right kind of value, right?
Yep.
But I'm interested if it's is left.
Yeah, so you
So-
return true for left and false for right, basically.
Yeah, is left. Do I have to construct it?
Yep, better match, but yes.
Yeah. Yeah. Okay.
Don't worry, I don't mind. I'll just correct you every time you say it wrong. But it's no problem. Yep, that's correct. Yep. There's a small typo here. It's a capital L, but and again, like you can do this here because you're not using, but that's perfect.
Yeah.
Okay. Okay. Okay, so let's see. What if so? How should I explain this in an easy way? Okay, we can do. Let's do the map left. So okay, what if I wanted to map left? Let me explain this to you first, and then maybe you can do map right, I guess.
Okay.
So let's say we have this, right? We have an either a, b, right?
Yeah.
And I want to change the left, right? Which means that I have a function from a to c, right?
Yeah.
Then I would get an either b, c, b, right? Because I want to change this bit here, right?
Yeah.
Using this function, right? So I need a for all a, b, c, and then map left. If I have a function f, right?
Yeah.
And I have a left a, and then okay, let's say f is a to c, right?
Yeah.
Then I can do left a to c a, and that's it, right? And if I have map left right b, then I can just do right b, right? Because right b works for both this and this, because it's also b, right?
Yeah.
It makes sense.
Yeah.
So can you write? Can you implement map right here?
Yeah. Wait, so I scroll a little further so I don't see the left one. Just so.
No, look at it. You don't need to.
Yeah. Okay. I wanted to see if I can. Okay, so now I know that I have to get from B to C because I want to change the right one, right?
Yes.
Okay, so it's either of I get an either of A, B, and I get an either of A and C.
Perfect. Yep.
Okay, case of it.
Okay.
So now I use the wait, B to C.
Yep. Yep. Perfect.
B, right? So I mean, okay, so this is in case I do have a B value, right? So this should be like no, is it like this?
Well, I mean, what's A and why the underscore?
So I don't get what the second step is doing. The second map, right? What is it supposed to do? Like.
So okay. So what does this?
Conditions do I get here?
Okay, so if we have a B, right? If we are in the case of the right B, we change the B to a C, right? But if we have a left, okay, we don't have to do anything, right? But we still have to tell the function what to do in that case, even if it's do nothing.
So map right of A and whatever else is here. Basically, there's nothing here, right?
Well, okay, so let me explain. First thing is it's not an A here, it's a B to C again, because it's the same function.
Okay.
right? And then here, what do you have here in the either?
I have an A.
But is
Right.
it just an A or is it a left A?
It's a left A.
Right. Okay.
Yeah.
And
It equals to
mhm.
left of A.
Yep.
Right.
So the thing is, you could say that, oh, why can I do this, like left A equals left A, and if we do this we'll get a compile error, which is a very weird compile error, but it's correct. So the LA here is an either AB, even though we know it's a left A, it's still it's still a like an either AB, right? So like it's not the same type. Even though we know it's a left and it's kind of the same thing as here, we kind of need to reconstruct it from scratch, if you will, right? So like this is of type either AB and this is of type either AC, right? Even though inside it it's the same value, it's actually a different type. Okay?
Yeah.
Cool. So yeah, we have to pattern match and do this, right? And the way, like, you can think of like left is a function from A to either AB, right? So this thing does not appear on the left hand side here. It's only here on the right, right? So like this one, like this left A is this type, right? And we need to change it to a AC, right? Even though this doesn't matter here, it shouldn't matter, it does, right? Because they're different types.
Okay.